So we're into 6G now. I just finished 5G. I was a leader on 5G getting that done. And now they're up to 6.
Let's do it again.
What does that do? Give you a little bit deeper view into somebody's skin? Give you a little bit deeper view into somebody's skin? A little bit deeper view into somebody's skin?
The weapons change over time.
Today, warfare has changed, again, dramatically. I don't mean just physical warfare of the kind I just described. I'm talking about the capacity, and it's not imaginary, it's not futuristic, and it's not exaggerated. It's moving very rapidly to a situation where, with the click of a button, you can bring down nations to their knees.
This is what proliferation of precision is going to do. And you're going to be able to attack with much smaller systems. And there's just going to be all sorts of stuff on the battlefield. So we're going to have unmanned systems to replace humans simply because we won't be able to afford all the humans we want. The third reason is, as you all know, war is amongst the people. And if you're going to use autonomous systems amongst the people, you have got to have the absolute highest level of trust in your autonomous systems, especially if they have lethal abilities.
So what have your neurons had to do on this slide? And this brings us basically to so-called converging technologies. So already kind of in the end of the last century, 25 years ago, in other words, people have been talking about the convergence between biotechnology, information technology, nanotechnology, and cognitive science. So our thinking was always part of the planning of converging technologies. Back in 2004, there was a New York Academy of Science conference on converging technologies, co-evolution of human potential with technology. In the same year in Europe, we had this brochure, Converging Technologies, Shaping the Future of European Societies. And it says nano, bio, info, cogno, socio, antro, philo, and goes further on the bottom. So it's this really an all-encompassing approach from the nano scale to the global scale. That was back in 2004, 20 years ago. What has happened since then? Well, among others, the so-called Internet of Bodies. Back in 2020, the World Economic Forum informed us that tracking how our bodies work could change our lives. Okay, we probably believe that. Collecting our physical data via a range of devices that can be implanted, swallowed, and worn. And then a few months later, they said the Internet of Bodies is here. Recent technological advancements have ushered in a new era of the Internet of Bodies, with an unprecedented number of connected devices and sensors being affixed to or even implanted and ingested into the human body.
Internet of Bio things, these are for the health applications. I did also a lot of research on that the last 15 years. Bio-nanoscale machines, but these are for the injecting into the body and always monitoring the health problems. And that is also really going really well, like with these COVID vaccines. It's going that direction. These mRNAs are nothing than small-scale, nanoscale machines, right? They're programmed and they're injected. And then Internet of Nanoscale things. So those will be part of 7G and beyond, right?
A little bit deeper view into somebody's skin.
With the click of a button, you can bring down nations to their knees.
With 5G here and 6G on the way, are we ready for the ethical storm that's brewing with all this new tech?
Right. This study by the European Parliament's think tank looks into exactly that. Apparently, the merging of AI with IoT and robotics is bringing both opportunities and unprecedented ethical challenges.
Okay, so what kind of challenges are we talking about?
Well, a big one is data collection. Apparently, these technologies could gather huge amounts of personal data, affecting even intimate aspects of our lives,
Smart homes, cities, and even smart bodies are on the horizon. what's the flip side?
Exactly. That's also mentioned in the study. As tech advances, things like love and friendship could be affected in ways we haven't really thought about before. It all sounds a bit dystopian, doesn't it?
Oh, wow. So the study offers policy options too, right?
Yes, it does. The study aims to give a broad view of these challenges and suggests ways to deal with them effectively, which is super crucial right now.
Okay, I see. It sounds like we need to think about the ethics as tech speeds ahead. Can you imagine a world where we could program cells inside the body to fight diseases? It sounds like science fiction, but it might be closer than we think.
That's right. There is a project, according to the material, by NanoCell, aiming to do just that with something called targeted nanoparticles. It's quite revolutionary.
So how's this different from current cell therapies like CAR T cell therapy?
Well, the article says existing therapies are expensive and complex. They require specialized facilities, which limits accessibility for many patients. These nanoparticles, though, could offer a more affordable and scalable solution administered in an outpatient setting. That is, if they work as planned.
Okay, so how do these nanoparticles actually work to program cells in the body?
The nanoparticles combine a T-cell binder with a gene editing system using something called a transposon. This allows them to create CAR T cells directly inside the body, that's in vivo, which cuts down on the cost and complexity.
This sounds like a complex undertaking. Who's involved in this project?
Well, NanoCell brings expertise in gene transfer tech. Other partners, like the University of Utrecht, bring knowledge in nanomedicine and cell engineering. Apparently, there are also machine learning components from QSAR.
So, if successful, what kind of impact could this technology have?
The hope is to make cell therapies more accessible. They could potentially treat a wider range of diseases, including cancer and genetic disorders, in a less invasive and more cost-effective way.
Today, let's explore how artificial intelligence and RNA nanotechnology are converging to revolutionize medicine.
Right! This destination project, funded by the EU, as detailed on Cordis, aims to deliver information into cells using an AI-enabled RNA delivery system.
So, what are the core challenges that this project is trying to address?
Well, mRNA, while vital, is fragile. It needs protection from degradation in the blood. Also, it should avoid triggering an immune response.
And I imagine targeted delivery is key here, right?
Absolutely. The system needs to be highly selective to ensure it reaches only the cells that require the information.
Where does artificial intelligence come into play?
The project utilizes AI and machine learning to create a library of these programmable RNA nanoscaffolds. These package the mRNA. RNA aptamers are also used.
And these aptamers help with what exactly?
Therefore, laser-specific internalization, guiding those RNAs into the cells with precision. So you can think of them as guiding beacons.
If destination succeeds, what would be the potential impact?
The implications are vast. Imagine cells producing their own medicine by replacing faulty mRNA, or engineering cells to combat genetic disorders and even cancer.
For clarity, what's RNA's role here in transferring information?
Right, so mRNA translates DNA's encoded information into proteins. It is the proteins that are essential for cell function. Administering mRNA could enable cells to fight diseases.
It sounds as though the clinical potential here is enormous. What an undertaking. Can you imagine a world with advanced sensors seamlessly integrated into our clothing, revolutionizing fitness and healthcare? It's closer than we think.
Oh, absolutely. The EU Trains project, coordinated by Silicon Austria Labs, GmbH, is making that a reality. It's about creating user-centric devices for both multi-sport training and remote healthcare.
So, what's the big problem it is actually trying to solve?
Well, it addresses the fragmented supply chain for high-quality sensors. Current tech often lacks the precision and durability needed for comprehensive monitoring, especially in challenging environments.
What are the goals of this project?
The project aims to establish a fully European supply chain for these sensors. It's focused on developing smart textiles and miniaturized devices, with AI-driven data processing.
AI-driven data processing sounds interesting. How exactly is that being used?
Okay, so the project combines cloud and edge AI approaches. This enables reliable diagnostics of body parameters through self-learning sensors, remote updates, and multi-sensing approaches using sensor arrays.
How versatile are these sensors really?
Very. The project develops sensors that can be integrated into textiles, smart wearable wristwatches, and even sport equipment for underwater applications. This includes real-time monitoring of heart and respiratory parameters.
So, what's the big picture? What are the wider benefits for society?
It is expected that these advancements will promote healthier lifestyles through affordable tools. Also, it will impact the remote healthcare sector by providing low-cost solutions for intelligent body sensors.
Today, we're exploring injectable wireless microsensors.
Right! According to Cordice, the EU Research Results website, these sensors represent a significant advancement in neuroprosthetics.
So, how do these injectable sensors work?
Well, they're based on the rectification of high-frequency currents and are designed to be minimally invasive.
Ah, it's all about reducing invasiveness, isn't it?
Exactly. The technology uses thread-like implants less than 1 millimeter in diameter, which avoids needing bulky components.
What is the aims of these sensors?
The project aims to pave the way for a spin-off that would further develop these sensors for specific clinical uses.
And what makes them different from existing technologies?
These sensors don't need batteries or coils for power, allowing for unprecedented miniaturization.
Where did this technology originate?
This all comes from the eAxon project, also EU funded, which focused on wireless microstimulators.
What were the primary goals?
The objective was to create very thin, flexible implants that can wirelessly transmit data about physical or chemical changes.
Under which program was SensoAxon funded?
It received funding under the European Research Council as part of the Excellent Science Program. This technology really opens doors for future advancements in medical implants.
Synthetic biology is about to get a whole lot more interesting. Imagine programming cells, like folding origami.
Right. According to Anderson's research, this approach uses RNA origami to redesign genetic elements from scratch. It's kind of like giving cells new instructions.
Okay, but how does folding RNA achieve that?
The RNA origami method, inspired by the Japanese paper folding art, involves folding a single strand of RNA. This enables us to genetically encode RNA nanostructures and express them in cells.
And I read that they developed software for designing these structures?
Yes, they succeeded in developing software tools capable of designing RNA origami structures of larger sizes and complexity. This software is open source and available to the research community.
So what does this mean for real-world applications, especially in medicine?
Well, a key strength is that these structures can serve as scaffolds to attach and organize molecular components within the cell. This has huge potential in medicine, especially with the rise of RNA-based vaccines.
It sounds like there's still plenty to explore.
Absolutely. Anderson is interested in pushing the technology further to understand RNA folding better, which could open new doors for RNA nanotechnology.
Imagine a world where medical diagnoses are quick, easy, and affordable. This project got one step closer to that reality.
Okay, so scientists, including MOE, explored using nanonets to integrate biosensors with COS tech. They wanted to create low-cost devices that could be used anywhere, like a doctor's office.
So, what's the big deal about these biosensors anyway?
Well, the current methods to quantify DNA involve expensive tools. This project aimed to provide point-of-care monitoring, which can be used for reactive treatment.
And that involves nanonates, right? What exactly are they?
Right, nanonets are basically random arrays of tiny nanowires. These semiconducting materials can be used for biosensing applications. The fabrication process is low cost.
Ah, okay. So how does the device actually work?
The sensors are placed directly on top of the readout circuit. That way they're in direct contact with the biomolecules being detected. The design also protects the electronics from fluids.
It sounds like a big step forward. What did the project actually achieve?
The project successfully created the tech to enhance CMO's chips functionality with nanonet-based biosensors. This is a completely new readout scheme. The goal is to realize full 3D integration of biosensors, and that opens the door to faster diagnoses and more personalized medicine.
Cordice informed us about the iGene project, also known as in vivo gene editing by nanotransducers. This project received about €3 million in EU funding. The project officially concluded on April 30th, 2024. You have access to public deliverables and publications. You can explore websites, patent filings, videos, documents, reports, demonstrators, pilots, and prototypes. You can also dive into peer-reviewed and non-peer-reviewed articles. The project also has information on intellectual property rights, including patents. Cordice provides these details for your convenience. Feel free to further explore this project and its available resources. Are you ready to explore how virus-like particles, or VLPs, are changing the game in gene therapy and vaccine development?
Okay, that sounds great. Researchers at Technische Universiteit Eindhoven are using them to deliver antigens, which could really improve how we prevent and treat diseases.
So, how do these VLPs actually function?
Right, they mimic the structure of viruses, but here's the cool part. They don't contain any viral genetic material. This means they can't cause infections.
Ah, that's clever. So where exactly are these VLPs being applied?
Well, one major area is vaccine development. Several commercially available vaccines already use VLPs to present antigens to the immune system.
It makes sense. Now, the article mentions using VLPs for carbohydrate antigens. What are those, and why are they important?
Right. Carbohydrates, or glycans, are found on the surface of pathogens and cancer cells. The problem is they're not very good at triggering strong immune responses on their own.
Okay, so how do VLPs help with that?
The VLPs boost the immunogenicity of these glycans. By attaching glycans to VLPs, researchers can create more effective vaccines, you see?
That's a great strategy. And what specific examples did the project explore?
One approach used the bacteriophage Q beta to target Streptococcus pneumonia. They were able to generate a much stronger immune response in mice compared to previous methods.
That's promising. What about cancer applications?
For cancer, they used the cowpea mosaic virus, CPMV, to deliver tumor-associated antigens like the teen antigen. Again, the results in mice were encouraging.
So what's the big picture here? What are the potential real-world applications of all this research?
It points to a new platform for developing vaccines against poorly immunogenic antigens. This could lead to new preventative and therapeutic vaccines, including for cancer.
Parkinson's and other neurodegenerative diseases pose a significant challenge, especially with aging populations. Finding effective treatments is a priority.
Right. According to this project overview from Cordis, cell replacement therapies are promising, especially with stem cell reprogramming. But controlling cell behavior after transplantation, that's where it gets tricky.
So the project introduces magnetic manipulation for remote control of cellular functions. How does that actually work?
It involves magnetic nanoparticles functionalized with proteins, biofunctionalized MNPs, they call them. These MNPs act as signaling platforms inside the cells.
And these platforms? They can be activated in a controlled manner using external magnetic fields, right?
Exactly. The focus is on controlling neuronal cell programming and fiber outgrowth. They're hijacking WNT and neurotrophin signaling,
with the ultimate goal of improving cell replacement therapies for Parkinson's, specifically using dopaminergic precursor neurons?
Precisely. To achieve this, the project brings together experts in BMNP engineering, surface functionalization, and cellular nanobiophysics. Also, experts in neuronal cell differentiation, stem cell reprogramming, and regenerative medicine.
So it's really about creating a versatile technology for magnetic control of intracellular signaling?
Yes, and the hope is that this will advance cell therapies for neurodegenerative diseases and injuries. It's a really ambitious goal.
It's fascinating how they're combining nanotechnology and cell biology to tackle such a complex problem.
Indeed. This interdisciplinary approach could really change how we approach cell therapies in the future, don't you think?
Absolutely. Thank you for shedding light on this innovative research. Today, let's explore how artificial intelligence and RNA nanotechnology are converging to revolutionize medicine.
Right. This destination project, funded by the EU, as detailed on Cordis, aims to deliver information into cells using an AI-enabled RNA delivery system.
So, what are the core challenges that this project is trying to address?
Well, mRNA, while vital, is fragile. It needs protection from degradation in the blood. Also, it should avoid triggering an immune response.
And I imagine targeted delivery is key here, right?
Absolutely. The system needs to be highly selective to ensure it reaches only the cells that require the information.
Where does artificial intelligence come into play?
The project utilizes AI and machine learning to create a library of these programmable RNA nanoscaffolds. These package the mRNA. RNA aptamers are also used.
And these aptamers help with what exactly?
Therefore, laser-specific internalization, guiding those RNAs into the cells with precision. So you can think of them as guiding beacons.
If destination succeeds, what would be the potential impact?
The implications are vast. Imagine cells producing their own medicine by replacing faulty mRNA, or engineering cells to combat genetic disorders and even cancer.
For clarity, what's RNA's role here in transferring information?
Right, so mRNA translates DNA's encoded information into proteins. It is the proteins that are essential for cell function. Administering mRNA could enable cells to fight diseases.
It sounds as though the clinical potential here is enormous. What an undertaking.
Absolutely, and it highlights the EU's commitment to advancing RNA technology for the benefit of all.
The healthcare sector faces increasing cybersecurity challenges with the rise of digitization. What are the key issues?
That's right. According to a report, the growing use of electronic health records and telemedicine introduces complexities and vulnerabilities. A universal cybersecurity approach isn't viable. Data should follow the patient, and professionals need to collaborate, making patient identity crucial for secure e-health.
So, what solutions are being developed to tackle these challenges?
The Panacea project is developing a cybersecurity toolkit. It offers a holistic approach with technical elements like software platforms for risk assessment and secure information sharing, alongside non-technical aspects such as procedures and governance models.
Can you elaborate on the specific areas where Panacea aims to advance the current state of cybersecurity?
Certainly. The project focuses on dynamic risk assessment and mitigation, using blockchain for secure information sharing, enhancing identification and authentication methods, and creating secure behavior decision models. It aims for healthcare facilities to fully understand their vulnerabilities.
How does Panacea ensure that these cybersecurity solutions are practical and effective for healthcare providers?
The project adopts a people-centric model. It emphasizes awareness of cyber vulnerabilities, enabling healthcare facilities to assess threats and decide on strategies to strengthen their preparedness and response. The project is end-user driven. The initiative seeks to improve cybersecurity in healthcare by focusing on awareness and practical solutions.
Thank you for sharing these insights into cybersecurity advancements in healthcare. Let's explore the Internet of Nano, biodegradable, and ingestible things.
Right. This survey paper from ArcSieve details the convergence of nanotechnology and biotechnology with the Internet of Things. It covers IoNT, IOBNT, IOBDT, and IoIT.
So we're talking about connecting very small materials and devices to the internet.
Correct. Think nanomaterials, nanoimplants, and nanobiosensors, all linked into existing IoT networks.
Okay, let's break it down. What exactly is nanotechnology in this context?
Well, nanotechnology involves studying and applying things on an atomic and molecular scale, producing new tech materials and devices.
And these nano things that the paper mentions, what do they do?
These are devices 1 to 100 nanometers in size that collect, compute, process, and transmit data at the nanoscale.
These networks have potential in fields such as healthcare.
Exactly. The Internet of Nano Things, Bio-nano things, biodegradable things, and ingestible things open doors in biomedical, military, environmental monitoring, and other fields.
Right. What's novel here is including the Internet of biodegradable things and the Internet of ingestible things.
Those areas haven't been surveyed as much. The paper aims to fill those gaps by looking at applications, architectures, and communication structures.
What challenges do these networks face?
The study emphasizes the challenges, open issues, and future research directions for these concepts.
So we're discussing the Internet of Bio-nano things, or IOBNT. What exactly is it?
Right. According to this IA paper, IOBNT envisions connecting biological cells to the internet. It aims to revolutionize biomedical tech.
And this paper proposes something called Panacea. How does that fit into the IOBNT concept?
Panacea is presented here as an end-to-end design aiming to realize IOBNT. It focuses specifically on the diagnosis and therapy of infectious diseases.
So Panacea's architecture is tailored for detecting and treating infections. How does it actually work within the body?
Okay, it proposes using implantable bioelectronic devices, these bio-nano things, to detect communication within cells and determine infection levels.
And then the BNTs transmit the infection data, is that right?
Yes, remotely to a wearable hub outside the body. From there, the hub uses the internet to reach healthcare providers who can then remotely control the BNTs.
The paper mentions challenges in incorporating molecular communication with conventional networks. Are there solutions proposed?
Yes, it does. The paper tackles challenges in circuit and biosensor design, communications engineering, presenting novel solutions with simulation results. All in all, it is a responsive system for detecting diseases and recovering from infection.
Can you imagine having tiny devices inside our bodies that communicate with each other? It sounds like science fiction, but it's becoming a reality?
Right. This article talks about the Weizerbing project and how they're developing ultra-miniature wireless microsystems. Vincent Pyrus, the project coordinator, says these devices could revolutionize medical and lifestyle tech.
So what exactly makes this project so special?
Well, current wireless solutions are just too big and power hungry for many applications. Weizerbin aims to create devices 50 times smaller and with 20 times lower power consumption than, say, Bluetooth devices.
Okay, that sounds like a huge step. What's the key to achieving that miniaturization and low power consumption?
The innovation lies in combining ultra-deep submicron CMOS circuits with MEMS devices. It also allows for a highly efficient startup time for the transceiver section, thereby enabling rapid wake-up of the radio.
It sounds complex. Were there any major hurdles in getting all of this to work together?
Yeah, system integration was a big challenge, making sure all the different components like antennas, chips, and software work together seamlessly. Close collaboration was key to overcome that.
Any other interesting results from the project?
They've developed miniature antenna prototypes that take into account the specific requirements of different housings, like hearing aids and cochlear implants.
Okay, so when can we expect to see this technology in our everyday lives?
The article says some technology Brits, like circuits or MEMS devices, could appear in semiconductor products as early as 2014, with complete integration in end-user products expected around 2015. It also opens the door for applications like smart skin for prosthetics or implanted neurostimulation solutions.
That's pretty exciting. Wireless technology is certainly going to change everything in the near future. Hey, imagine tiny nanoworks inside our bodies, revolutionizing medicine. I mean, it sounds like science fiction, right?
It does, but it's closer to reality than we think. Scalian project explored using terahertz frequencies for in-body nanonetworks. It's all about making these networks scalable and precise.
Scalable as in how many devices are we talking about, and precise as in pinpointing their locations?
Yeah, the project aimed at enabling communication between numerous nano devices, all while accurately tracking their positions within the body.
So what did they achieve that wasn't possible before?
Well, they pushed the boundaries of terahertz communication for nanonetworks. They're talking about creating networks that can adapt to the body's environment.
Adaptive networks, that's really clever. What's the big picture? What's the end goal?
Think targeted drug delivery, real-time health monitoring. The potential impact on medicine is huge.
Okay, but is there more to it than just treating diseases?
Absolutely. Improved diagnostics, personalized medicine, and reduced healthcare costs are all on the table.
Sounds almost too good to be true. So are we close to seeing this in real life?
There's still work to be done, but Skaten has laid a solid foundation.
Today, we're exploring continuous biosensing and how it's changing personal monitoring.
That's right. According to the Cordis EU research results, the Concerns project is really pushing the boundaries of what's possible.
Blood tests only offer a snapshot, but continuous glucose monitoring has transformed diabetes care. Why can't we do this for other critical molecules?
Precisely. Currently, continuous sensors are available just for glucose. The need is to expand this to peptides, proteins, hormones, and even drugs.
So what exactly is Consents aiming to achieve with these new sensor technologies?
The project intends to combine molecular engineering with optical detection for affinity-based biosensing. This could really revolutionize patient monitoring.
Nanoswitches are mentioned. What is their role in all of this?
They're key. These nanoswitches translate molecular binding into conformational changes, which optical detection methods can detect. This allows differentiation between specific and non-specific binding.
The project's focus is on immune monitoring and critical care. Why this specific area?
In critical care, continuous monitoring is vital, especially related to inflammation and immunotherapy. It allows for timely interventions.
The initiative involves training and collaboration. How does this contribute to its goals?
Concerns brings together pioneers in biomolecular switch engineering with experts in biosensor development. They also have a network of partner industries for technological expertise and training.
So what is the potential impact of this research in the long run?
The potential here is enormous. This research could fundamentally advance continuous biomolecular monitoring for healthcare, leading to truly personalized therapy.
It seems like we're on the cusp of a significant shift in how we monitor and manage health. Imagine having chronic diseases detected years before symptoms appear. How close are we to that reality?
That is the promise of the Benefit Project from the European Union's Cordis program. It explores using nanoscale communication systems inside the body for faster, cheaper, and less invasive diagnostics.
Less invasive, okay. What are the real game changers here?
Well, currently, diagnostic turnaround times can be as long as 10,000 minutes. Benefit is aiming for a reduction to just a few tens of minutes. That's a 1,000x improvement.
Amazing. What exactly will these nanomachines be looking for?
The project focuses on highly accurate in vivo detection of biomarkers, using nanomachines equipped with biosensors. These sensors use a cooperative approach to maximize sensitivity and specificity.
So this could really revolutionize healthcare?
Absolutely. Benefit aims for a greater than 95% detection accuracy and a 10-fold reduction in treatment costs. The project is developing open source tools to analyze the impact of design choices to ensure safety and efficiency. If this project delivers on its promises, we could see a real shift towards faster and more affordable diagnostics.
Can you imagine targeting medication with magnets? It sounds like science fiction, but it's becoming reality.
Right. A project from Universidad del País Vasco explored using injectable hydrogels for remote-controlled drug delivery. The idea is to guide drugs precisely where they're needed, minimizing side effects.
Okay, but how do these hydrogels actually work, and how do magnets play a role?
Well, the hydrogels can have magnetic particles embedded in them. This allows them to be manipulated using external magnetic fields for targeted drug release.
So it's like a GPS for medicine. What are the real-world benefits of this kind of targeted approach?
Exactly. You improve drug efficacy, reduce the dosage needed, and limit exposure to healthy tissues. The study also looked at understanding mass diffusion in hydrogels, aiming to improve drug delivery systems.
Got it. So less collateral damage in the body. What's the potential socioeconomic impact?
There is potential for a significant impact. More effective treatments, reduced healthcare costs, and a better quality of life for patients are all possibilities.
Imagine detecting viruses in minutes with just light. Sounds like science fiction, right?
Okay, so That's actually the goal of the Virusong project. It's led by the Université Lyon, France. It explores using light to identify viruses really quickly.
How would it work? I mean, viruses are so small.
Right. The idea is that viruses, they vibrate. They have like unique vibrational modes. The project aims to measure these vibrations using light scattering.
Okay, but wouldn't the light be too weak to detect those vibrations?
Yeah, exactly. That's the challenge. So they're trying a couple of things. One is to couple the viruses with nanoparticles that amplify the signal.
Interesting. And what's the alternative approach?
It involves using stimulated inelastic spectroscopy. This allows for label-free detection of any virus type.
So they get all this vibrational data. How do they actually identify a specific virus?
Oh, this is where artificial intelligence comes in. They're using AI to correlate the vibrational spectra with the virus's characteristics, basically teaching a computer to recognize each virus's unique song.
That's incredible. This could really transform how we detect and respond to outbreaks, right?
Definitely. Imagine rapid, specific, and sensitive virus identification down to a single particle. The potential is just enormous.
Let's delve into the Bessel project as detailed by the European Union's Cordia service. The project is focused on advancing wireless medical devices. These devices can be implanted for health monitoring and delivering therapies. Bessel aims to develop technologies for powering and controlling these devices from outside the body. The project will study wave behavior in anatomical environments. It will create radiating surfaces and demonstrate clinical utility. This will be done through wireless recording and modulation of pancreatic nerve activity. The project is funded by the European Research Council with a contribution of 1,499,973.00. The Centre National de la Recherche Scientifique CNRS in France coordinates it. Bessel has a strong focus on digital technologies. It also contributes to clean air initiatives, artificial intelligence, and climate action. This project is expected to run until February 2030. So let's explore how nanotechnology could be part of the solution to antimicrobial resistance.
Right. According to Cordis, the EU's Research and Development Information Service, antimicrobial resistance is a major global health concern. The Project Rebellion aims to develop alternatives to traditional antibiotics.
These alternatives involve molecular nanomachines. Can you explain how these work?
Oh, sure. Molecular nanomachines are synthetic molecules. They can penetrate lipid bilayers using a rotational movement to essentially inactivate bacterial pathogens.
And Rebellion focuses on light-responsive nanomachines. Why light?
The idea is that light responsiveness allows greater selectivity. It also minimizes damage to mammalian tissues and reduces the potential for antimicrobial resistance development.
The project aims to achieve several objectives. What are the key goals?
The objective include synthesizing new M&Ms, assessing their efficacy against bacterial pathogens, also evaluating their safety to mammalian cells, and in vivo efficacy testing.
What are some of the expected outcomes of this research?
Well, the results could lead to an entirely new class of antimicrobials and pave the way for future clinical trials. A big step, really.
It sounds like the project's impact could extend beyond just creating new antimicrobials.
Oh, absolutely. It could also contribute to European excellence in antimicrobial discovery technology and also offer hope against the growing threat, posed by antimicrobial resistance. It's a crucial area of research, and these light-responsive nanomachines offer a promising path forward.
Did you imagine tiny machines inside bacteria that help them move? It's like something out of a sci-fi movie, really.
Right. According to Humboldt University, these bacterial flagellas are fascinating examples of complex nanomachines. They're made through the self-assembly of different proteins.
Okay, so how do these flagella actually work?
Well, they function as motility machines. The building blocks assemble in a coordinated manner, which allows the bacteria to move towards nutrients.
So it's all about how these tiny parts come together.
Exactly. Previous studies focused on genetics, but now the idea is to really understand how bacteria orchestrate these processes to construct a functional organelle.
Okay, so if researchers figure this out, what's the big deal?
It could advance understanding of self-assembly processes. It may also have implications for the rational design of novel antibiotics and for synthetic molecular machines.
And how exactly are they planning to study this?
The project combines visualization of the dynamic self-assembly of individual flagella with quantitative single-cell gene expression analyses. Also, biophysical modeling will be done.
That sounds extremely complex. What are some of the challenges they face?
Well, bacteria orchestrates many cellular processes in time and space, so it's hard to construct a functional motility organelle. Scientists still have to figure out how they do that.
This research sounds like it could really change how we think about these tiny machines.
Definitely. A deeper understanding of bacterial nanomachines could lead to groundbreaking developments in medicine and technology.
Electromagnetic waves drive so many advances. We're exploring how they're being detected.
Indeed. According to the EU-funded Thor project, there's been impressive progress in devices that operate at frequencies either below 0.1 THz or above 50 THz.
However, it seems there's a significant gap in the terahertz range. A missing piece.
Exactly. There's a lack of systems that perform well in the 0.3 to 30 TH region. That's why it is often called the terahertz gap.
So, what is the Thor project trying to achieve in this area?
The project aims to demonstrate a fast, low noise, and cost-effective nanodetector, and you will operate at room temperature.
That sounds very innovative. What's the core technology behind this nanodetector?
It builds on breakthroughs in molecular cavity optomechanics. It leverages molecular design to transfer energy from the THZ range to visible light.
The project description mentions signal-up conversion. How does that work?
It involves designing molecules with both IR and Raman vibrational activity. These molecules are integrated into nanocavities to mediate the transfer of energy.
And I read that THZ antennas are being used. What role do they play?
They improve the coupling efficiency of the THZ field to the molecules. This enhances the overall performance of the detector.
It sounds like this could have a broad impact. What are some potential applications of this technology?
Applications range from medical diagnostics to security, astronomy, and even wireless communication. Overcoming the THZ gap could revolutionize these fields.
The text mentions on-chip integration. Why is that important?
It's about making the technology more accessible and easier to manufacture. Integrating it onto a silicon chip makes it compatible with existing technology. This is a unique project. The TA Thor project offers a completely new way of measuring and manipulating TEG molecular vibration.
Let's delve into the synergy of artificial intelligence with XL MIMO for terahertz communication and sensing.
Right. According to the Cordis, this project aims to tackle challenges in 6G communications by combining terahertz tech with extremely large-scale MIMO. It's about achieving hyper rates, terabits per second.
Okay, but what is the big hurdle with terahertz communication that XL MIMO helps overcome?
Well, the main issue is increased path losses. XL MIMO, with its multiple inputs and outputs, compensates for this, offering spatial degrees of freedom and ultra-wideband capabilities.
So the combination is crucial for integrated sensing and communication. What exactly is ISAC?
Right, it's about meeting the needs of ISAC, which includes high-precision target sensing and high-throughput communications. But the large antenna aperture of XL MIMO brings near-field communications to the forefront.
And there is also the beam split effect, is that right?
Yes, precisely. The ultra-wideband nature of terahertz signals introduces the beam split effect. So there's a need to synergize AI with XL MIMO, taking these unique characteristics into account. It's all about designing AI-native XL MIMO terahertz communication.
What are the project's key objectives to achieve this?
They include developing learning-aided channel estimation methods for XL MIMO communication systems. Also, intelligent precoding to manage hybrid field interference, for mixed near-field and far-field communication users.
And what about the ISAC precoder?
Yes, the project also aims to develop an ISAC precoder for target and electromagnetic property sensing. Plus, a network-level ISAC performance analysis framework is in the works. These guys are also thinking about the practical implementation.
In what sense?
By developing resilient AI-native XL MIMO ISAC. They're using a generative diffusion model and an intelligent XL MIMO ISAC testbed. Electromagnetic wave theory, nonlinear optimization, and reinforcement learning will also be employed. This research could really pave the way for the next generation of wireless communication.
According to Cordis, the 6J Scout project is shaping the future of ultra-connected networks. The project is pioneering integrated sensing and communication, merging sensing and data transmission for smarter, more efficient networks. It's designed for emerging applications like smart cities and autonomous systems. 6G SLT aims to boost network accuracy for localization and object recognition, while optimizing resources using machine learning and real-time testing. Beyond technology, the project fosters collaboration and standards that place European values at the heart of 6G, promising a connected and responsible world. Consider this project as the future unfolds. I came across some pretty interesting material from the Walton Institute. Are they making headway with brain malignancies?
Indeed. The Gladiator project aims to revolutionize cancer monitoring and therapy. It's a collaboration across Europe and even with a university in Japan.
Bio-nanomachine diagnostics? That sounds incredibly futuristic. What does that even mean?
It involves creating networks of bio-nanomachines that can be controlled externally. This allows to extract information about the cancer and also manipulate its progression through externally controllable molecular communications, or ECMC.
And this could actually improve a patient's prognosis?
That's the hope. The project anticipates improving patient outcomes, minimizing recurrence, and even reducing the toxicity of drugs. Improved health, extended life expectancy, it's all part of the vision.
What are the concrete goals of the project?
Well, they're using glioblastoma multiform tumors as a proof of concept. The idea is to create a platform with cell-based and electronic components that autonomously monitors tumor evolution and recurrence.
Sounds ambitious. What kind of components are we talking about?
There are implantable cell organoids, a hybrid bioelectronic interface, and a wireless ECMC network. Ultimately, it should lead to autonomous, closed-loop devices for managing diseases. The Gladiator project, backed by the European Union, could really transform how complex malignancies are investigated and managed. Keep an eye on Walton Institute's research.
We'll be discussing biocyber interfaces for intrabody molecular communication systems.
Right. According to this paper from ArcSieve, these systems could revolutionize telemedicine and health monitoring.
How is that?
Well, the paper mentions wireless medical telemetry. Healthcare workers could remotely monitor patients' biological signals.
Okay, so real-time health monitoring. What about the bio-nano devices it mentions?
They could promote real-time monitoring and even store collected data in the cloud. It opens up possibilities for biosensing networks.
Right. So how do implantable microscale devices fit into this?
The paper reviews recent progress and suggests improvements. The aim is to develop new theranostics using nanoscale data.
So it's not just monitoring, but also therapy?
Exactly. This approach creates new opportunities for using data collected at the nanoscale level, which is pretty cool. It seems like we're on the verge of some major advancements in how we monitor and treat health conditions.
Absolutely. It is transformative indeed. The current mobile networks struggle to keep pace with data-intensive applications. Let's explore ultra-fast networks.
Right. According to Cordis, the 6G terabit project tackles ultra-high data throughput, focusing on the potential of millimeter and terahertz wave bands.
Impressive. So what are the current limitations of 5G that necessitate this shift towards terahertz communication?
5G falls short of meeting the demand for terabits per second, which is needed for future application. We're talking about speeds that 5G simply can't deliver.
Okay, so what exactly is the core objective of the 6G terabit project in addressing these limitations?
Well, it aims to bridge the gap between researchers and engineers. The project wants to foster collaboration for ultra-fast network development.
Beyond the tech, it seems there's also an educational aspect. Could you elaborate on how the project is nurturing future leaders?
Exactly. It serves as an educational platform. The idea is to nurture future leaders in the telecommunications field. That's right.
The text mentions achieving very high spectrum efficiency. What are the challenges in reaching those levels?
Achieving high spectrum efficiency, much higher than 10 bits/hertz in millimeter wavebands, is a significant challenge. So the project explores using the larger bandwidths available in TH bands instead.
Right. How does the design of ubiquitous access play into mobile and heterogeneous network environments?
It's key to developing future mobile networks, enabling very high rates in diverse network setups. It's all about making sure everyone can connect everywhere.
The project is committed to creating an excellent educational training platform. Could you expand on the project's broader impact?
Of course, it has a commitment to being multidisciplinary and intersectoral. That means bringing together different fields and industries to push the boundaries of what's possible.
Today, let's explore the 6G XR project, an initiative pushing the boundaries of extended reality.
Right. According to the Cordis website, this project aims to develop an experimental research infrastructure. This will enable the validation of beyond 5G and 6G technologies.
Extended reality, or XR, encompasses virtual, augmented, and mixed reality. What role do B5G and 6G play in advancing these technologies?
Well, these immersive technologies merge the physical and virtual worlds. This is largely due to advancements in beyond 5G, B5G, and 6G.
So the 6G XR project is developing an experimental infrastructure. What key elements does this infrastructure include?
The initiative features a B5G architecture that will eventually evolve into 6G. This includes end-to-end service provisioning, which is implemented in the cloud.
The project also involves multi-access edge computing, or MEC scenarios. How are these integrated into the cloud structure?
Right, these MEC setups are integrated into a comprehensive cloud continuum. The project supports demanding applications, such as holography and digital twins.
Besides the technical achievements, what other impacts are expected from the 6G XR project?
The project should contribute to standardization efforts in the field. Also, it aims to reduce energy consumption, which is crucial for sustainable technology.
So, the project addresses key societal needs, like reducing energy consumption. It will also test innovative uses of radio spectrum technologies.
Exactly, and that includes sharing capabilities applicable to B5G and 6G spectrums, which validates end-to-end architectures. This should also support vertical actors. It's very exciting. This EQ-funded project is really paving the way for future advancements. These include technologies that should transform our interaction with digital and physical environments.
Indeed. The 6G XR project appears poised to shape the future of extended reality and wireless communication. Let's explore the potential of 6G molecular communication. It's quite promising for diagnostic systems.
Right! This paper from the 2021 International Conference on Green Energy Computing and Sustainable Technology highlights its use in Internet of Bio-Nano Things Diagnostic Systems, or IOBNT.
IOBNT, So, what advancements make this possible?
Well, advances in synthetic biology have created molecular machines. These machines can perform actions like targeted drug release.
So it's like tiny robots inside the body. Is that how they communicate?
They communicate via molecular communication. Recent studies combine this with traditional electromagnetic models for hybrid IOBNT systems.
I see. What role do blood vessels play in all of this?
The blood vessels are key. They can form a communication system throughout the body to convey signals measured by sensors.
That sounds incredibly useful for monitoring. What about security and triggering communication?
There's an increasing need for secure, event-triggered communication. This is particularly important in IOBNT and medical contexts.
Definitely a must-have. What role does 6G play in this?
6G offers suitable frequency bands for the Internet of Bodies. This can be achieved through beamforming tech.
Interesting. What are some of the limitations of molecular communication right now?
A critical limitation is the absence of integrated computational functionality. Many scenarios require processing molecular data in real time.
Right, makes sense. Beyond diagnostics, where else can we see this tech being applied?
It's also being looked at for targeted drug delivery and disease monitoring. So, quite a bit of potential. This technology holds tremendous promise for future healthcare.
The landscape of wireless communication is about to change, potentially in a very big way.
Right. According to this article from the National Institutes of Health, we're looking at the rise of 6G. This new tech promises to take wireless capabilities far beyond what we can even achieve with 5G.
So what exactly makes 6G stand out from its predecessors?
Well, 6G aims for data rates reaching up to a terabit per second. Also, it will have a latency of less than 1 millisecond.
That's incredibly fast. How will 6G achieve these speeds?
It plans to utilize the sub-terahertz and terahertz spectrum from 300 gigahertz to 10 terahertz. This is significantly higher than what 5G uses.
Okay, so it's using a different part of the spectrum. What other technologies are key to making 6G a reality?
Reconfigurable intelligent surfaces are crucial, in addition to cell-free massive MIMO and, of course, artificial intelligence.
And what kind of applications will all this enable?
Think holographic communication, multi-sensory extended reality, the tactile internet, and just so much more, really.
It sounds like 6G has the potential to revolutionize connectivity. What challenges do we need to consider?
Things like the social, psychological, and even the health implications of this tech, plus, of course, figuring out how to commercialize it effectively. But the possibilities for sustainability and new business models are definitely there.
What are the key principles for the research and development of 6G wireless communication systems?
According to a recent statement by the Government of Canada, in collaboration with other nations, the principles encompass security, openness, and resilience. The focus is on fostering global connectivity that is both secure and interoperable.
Can you elaborate on the security measures outlined for 6G technologies?
Certainly. The principles emphasize the need for systematic approaches to cybersecurity, incorporating security by design to ensure the availability of essential services. They also prioritize the protection of individual privacy and the mitigation of risks associated with network complexity.
What role does international collaboration play in the advancement of 6G technologies?
International cooperation is deemed essential. The aim is to promote open, secure, resilient, and interoperable networks through initiatives like open radio access networks. Joint research, development, and testing are encouraged, leveraging technologies such as virtualization and artificial intelligence.
How do these principles address sustainability and affordability in the context of 6G technologies?
Energy-efficient deployments and operations are prioritized to improve environmental sustainability and ensure equipment repairability and recyclability. Affordability is addressed through economies of scale, standardization, and a competitive environment to bridge digital divides and deliver reliable coverage. These principles collectively aim to guide the development of 6G towards a future that is not only technologically advanced, but also secure, sustainable, and inclusive.
Can you imagine a future where technology and biology are so intertwined that they're almost inseparable? It's closer than you might think.
Okay, so this paper by Policy Horizons Canada, it really dives into what they're calling biodigital convergence. It's about how digital and biological systems are merging.
Right, yeah. It sounds like there are a few ways this convergence is happening, right?
Exactly. There's the physical integration, where you've got digital tech embedded in organisms and biological parts in digital systems. Also the coevolution.
Coevolution makes sense. How advances in one field drive the other forward.
Yeah, like gene sequencing and AI working together. The last bit, the conceptual convergence, might be the most interesting. It's how our understanding shifts when we view biology through a digital lens, and vice versa.
So, what would a biodigital system even look like in practice?
Well, according to the paper, things could become more democratized, decentralized, and geographically diffused. Also, customization. We might also see a bigger reliance on data.
I guess all this convergence would need a ton of data to actually function.
Absolutely. Managing, sharing, and governing that data becomes crucial. It sounds like this biodigital future could really shake up how we think about, everything.
I imagine this raises some pretty big policy questions. What kind of questions are we talking about?
The article touches on economic, social, environmental, geopolitical, and governance issues. For instance, how do we adapt education for potential skills gaps or foster trust around these technologies?
This sounds like it's not just about technology, but also how we, as a society, adapt and evolve. Food that is customized to your digestive system? Wow.
Right. It's a really complex picture with lots of possibilities. Getting a handle on this biodigital convergence, crucial for the future.
Definitely food for thought. It sounds like there are a lot of opportunities, but also a lot of potential pitfalls to navigate as we move forward. Hello! Today we will be discussing biodigital convergence and Canada's role in exploring this field.
Indeed. According to Vanderbelsk's work, this convergence involves merging digital technologies with biological systems, potentially revolutionizing industries like healthcare, manufacturing, and agriculture.
I see. And Canada is at the forefront, leading international efforts through the IEC. Can you tell us more about that?
Canada is leading the Standardization Evaluation Group, SEG 12, which assesses the long-term impact, benefits, and challenges of biodigital convergence. This group is composed of global experts and is tasked with proposing a roadmap for standardization in this area.
Why is standardization so important in a field like biodigital convergence?
Standards will shape our biodigital future by helping to evaluate the impact, benefits, and challenges of this field. They will play a key role in answering how it may transform economic and trade models and even redefine what we consider human.
In closing, any thoughts on the potential this presents?
The potential impact of biodigital convergence on commercial sectors and our daily lives is enormous. Canada's leadership in this area is a significant win, offering an exciting opportunity to shape our future.
Isn't it amazing how seemingly different fields are starting to merge, like biology and digital tech? It's wild.
Okay, that's right. This article by the IEC editorial team talks about something similar, how biodigital convergence needs standards to really take off.
Standards, so like making sure everyone's on the same page as tech gets more complex?
Exactly. This Francois Collier, he leads the SEG 12 group, says a systematic approach is key. It's about getting experts from all fields to collaborate. Also, that group is also working on common terminology.
So what areas are we talking about here? Just general tech or something more specific?
Oh, it gets pretty specific. We're talking genomics, neuroscience, even stuff like brain-machine interfaces, But there are also some synergies with different technical committees.
Wow, that sounds really interesting. It also sounds a bit like it could open up a can of worms. Are there any, ethical concerns being addressed?
Definitely. The article mentions a dedicated working group that's looking at environmental, social, and ethical risks. It is important to consider all of these factors.
It sounds like a tricky balance to strike between, standardizing too early and stifling innovation, right?
It is. According to Collier, getting in early can boost competition and innovation. It's about figuring out when to step in to help things along.
So what's next? I mean, is this just the beginning?
Yes. After SEG 12, the final report may set the stage for a systems committee to facilitate standardization in this area.
Okay, it sounds like this field has the potential to change everything, and having standards in place is going to be pretty important. Thanks for breaking it down. Biodigital convergence, huh? Sounds like something straight out of a sci-fi movie. What exactly is this new committee at ISOT and IEC all about?
Right. Well, this Joint Systems Committee, supported by the Standards Council of Canada, focuses on standardization at the systems level for biodigital convergence. It's essentially bridging the gap between biology and digital tech.
Okay, so what kind of work will the IEC/ISO Joint Systems Committee on Biodigital Convergence actually do?
The committee will facilitate engagement across different standards bodies and industry groups. The goals are identifying existing relevant standards, pinpointing any gaps, and anticipating new issues in biodigital convergence.
Are they working with other committees?
Yes, the committee liaises with others. For example, IC/TC 215 on health informatics can access the documents of IEC/ISO. Also, ISO/IEC JTC 1/SC 44 on consumer protection in the field of privacy by design can access the documents of IEC/ISO. If listeners are interested in contributing to the standards development in this area, they can check out the ISO website for more information.
Great, thanks for clarifying all of that. Hello and welcome. Today we're discussing an important initiative regarding biodigital convergence.
Thank you. That's right. ANSI recently announced a call for participants to get involved with the IEC/ISO Joint Systems Committee on Biodigital Convergence, or SICE-BDC. This committee aims to standardize systems-level activities within the biodigital convergence domain, particularly concerning information technology.
What are the main objectives of this committee?
The SICE-BDC has a couple of key goals. First, it wants to promote outreach and influence in the biodigital convergence space, working with ISO and other standards bodies. Second, the committee will identify emerging issues in biodigital convergence that could impact IEC activities.
How can interested individuals get involved?
ANSI is seeking an administrator and participants for the USNC Technical Advisory Group, or TA, to SICE-BDC. Those interested can contact Betty Barrow at ANSI.
What exactly does the USNCTA do?
The USNCTA develops U.S. positions on technical and policy issues being discussed within the IEC. It's open to all U.S. parties who are directly affected by the work of the IEC committee.
Thank you for clarifying the details of this important initiative. Bioconvergence in Israel. It sounds like science fiction becoming reality. What's driving this push?
It's fascinating. The Israel Innovation Authority is really trying to create the right environment for bioconvergence to flourish, aiming to make the country a world leader in the field.
And what exactly does this program focus on?
Well, it is multidisciplinary. The focus is on merging biology, engineering, and computation to tackle complex issues. And they're encouraging entrepreneurs, researchers, and investors to get involved.
Got it. So what kind of support is available for companies in this sector?
They're focusing on several key areas. This includes specialized infrastructure, R&D funding, talent development, and regulatory support to streamline innovation while ensuring safety. All of these initiatives are designed to help companies scale.
That sounds comprehensive. I see they also have a call for proposals. What's that about?
Yes, there's a call for agritech pilots in the Tacoma region in collaboration with the Ministry of Agriculture. It is targeting companies with advanced projects that need real-world testing. The Innovation Authority really seems to be pulling out all the stops to foster this industry.
Ever wonder how we're engineering life itself to tackle climate change and revolutionize industries?
That's exactly what Orly Savion, CEO of Allogene, discussed with Alan Trikaspa. They looked at how synthetic biology and bioconvergence are already making waves.
So why is Israel such a hotspot for these breakthroughs?
Well, it's a mix of cross-disciplinary collaboration, an entrepreneurial spirit, and really strong ties between academia and the tech industry. Apparently, this creates an agile environment where innovation just thrives.
How do these fields intersect with high-tech sectors like climate, agri-food, and health?
Synbio uses engineering principles to design organisms for specific tasks, from biofuels to sustainable materials. When you merge Synbio with other fields like AI and nanotech, that's bioconvergence. Together, they enable the development of multifunctional technologies that tackle multiple global challenges.
What role does Allogene play in all of this?
Allogene provides R&D services to support biotech innovations. They help companies develop new biomanufacturing processes and engineer microorganisms for specific applications. So it's really about creating sustainable biological solutions.
What's happening on a global scale?
There are breakthroughs in gene editing, synthetic genomes, and biomanufacturing platforms all over the world. Israel's keeping pace through its startup ecosystem and collaborations with global leaders.
Speaking of collaborations, are there any interesting examples between Israeli academia and industry?
Oh yeah, there are many. For instance, Phytolon and the Weizmann Institute of Science are reinventing food color production using engineered microorganisms. Another one that comes to mind is Imagine Dairy partners with Tel Aviv University to produce dairy proteins without cows.
What are the biggest challenges and future trends in Synbio and bioconvergence?
Scaling solutions from lab to industry is a big hurdle, and regulatory frameworks need to catch up. Looking ahead, advancements in gene editing and biomanufacturing will shape the future. It'll be interesting to see how that plays out.
So it sounds like synthetic biology and bioconvergence are not just futuristic concepts, but are actively transforming our world right now. Bioconvergence, it's the next big thing, right? Is Israel really poised to become a leader in this field, merging biology and tech?
Absolutely. According to Biodesign Israel, bioconvergence could be Israel's next economic engine. It's about integrating academic knowledge, industry innovation, and even clinical trials within the country.
Okay, but there is a gap, right? How does Biodesign Israel actually bridge the gap between different sectors and industries in bioconvergence?
Biodesign Israel focuses on fostering collaboration. They emphasize a needs-driven approach. It builds bridges using a common language that everyone can understand, with the need really taking center stage.
Got it. And what's their actual mission, in practical terms?
Their mission is threefold, actually. Education, focusing on methodologies that shift innovation to be needs-driven, and creating a common language for everyone involved, from researchers to clinicians. With bioconvergence gaining momentum, Israel has a real opportunity to lead. To explore this further, you can check out the case studies Biodesign Israel has on their website.
And then I was just going to finish with 2 points. There are two exciting things happening in the world of technology coming right now. One is as AI become the new form of computing, AI is going not only to the data center, but to everything, to cars, to PCs, and we see now the ability to run models that you can only run AI in the data center. You can run that on a microcomputer, on a computer for Enrique, on a server, with small server on premise. So I think we're going to see the proliferation of AI. The other one is 6G. We had made commitment working with your administration, working with FCC. We're going to accelerate 6G. We're working to have a launch first in the world in the LA Olympics. And I think that's another opportunity for America to lead in the next wireless evolution. So thank you. I thank you for the opportunity. Thank you for the partnership. And we're going to be hard at work, I think, driving that agenda.
So we're into 6G now. I just finished 5G. I was a leader on 5G getting that done. And now they're up to 6.
Let's do it again.
What does that do? Give you a little bit deeper view into somebody's skin? See how perfect it is? I like the cameras the old days. So they just had a nice feature. Now they cover every little. Let's see, Michael, you're in good shape. You're not gonna. But I tell you, it's the 6 is coming, huh?
It's coming.
Does it ever end? And what happens? You'll be into 7, right? Before 6 gets old, you'll be into 7.
In terms of bio things, these are for the health applications. I did also a lot of research on that the last 15 years. Bio-nanoscale machines, but these are for the injecting into the body and always monitoring the health problems, and that is also really going really well. Like with these COVID vaccines, it's going that direction. These mRNAs are nothing than small scale, nanoscale machines, right? They are programmed and they're injected. And then Internet of Nanoscale things. So those will be part of 7G and beyond, right?
Cancer diagnosis using AI has the promise of just being a simple blood test. Then beyond that, once we gene sequence that cancer tumor, you can then vaccinate the person, design a vaccine for every individual person to vaccinate them against that cancer. And you can make that vaccine, that mRNA vaccine, you can make that robotically, again using AI, in about 48 hours. So imagine.
We think that wearables are a key to the MAHA agenda, making America healthy again. And we are going to, my vision is that every American is wearing a wearable within 4 years. My vision is that every American is wearing a wearable within 4 years.
Wearable devices. So these are brain sensors that are starting to be embedded in everyday devices, but until now have been a number of niche companies that really have focused on mindfulness and meditation. The use of, for example, brain sensors that can pick up electrical activity in the brain at a pretty low resolution, but advances in AI have both improved what the signal is that can come from the brain and enabled the miniaturization of those products. As a lot of the major tech companies start to invest in these brain sensors, it's a huge, I think, untapped market in many ways of integrating them into everyday devices. These are earbuds or watches or headphones and the soft cups around the ears. Many of those products are hitting the market this year, and others are hitting them within the next 2 years, such that people can listen to music, a phone call, etc., while having those devices in ears. Initially, what they will be capable of doing is very high-level brain state reading. Things like, are you tired? Are you paying attention? Is your mind wandering? Are you happy or sad? They maybe enable interaction like up, down, left, right for interaction with other technologies. And they're being embedded into things like virtual reality headset.
To visualize this coming onslaught of data from a variety of sources. And also the fact that the human body is really poised to become the key node on the network. I'm sure Oleg will talk about the Internet of Things, but the sort of the Internet of Everything, where the human body really becomes a central piece. And one of the, I'll talk about a little bit later, I suppose, one of the strategies of pulling this together is really creating interdisciplinary groups of people who up until now might not have realized that they have a lot to talk about. We're going to have new models of content, and a lot of the content will come from the body, and sort of working on a vision of, in a sense, the computer exploding onto the built environment, so that information is displayed everywhere, coming from a variety of sources. And the linchpin of this, I think, is going to be the body and biometrics.
And the question is, what may be the effects of 6G on human health? What would you say that could be?
Well, I think I already addressed that. I mean, I think, one of the great capabilities of even 5G and going forward into 6G is, health, body area networking, where you can monitor what's going on in your body, in real time, and it can be, downloaded to your cell phone for analysis and so forth, or it can be transmitted to your physician for analysis. So people with, for example, heart conditions, rather than being monitored once a month, they can be monitored in real time, and data analytics can be used to let them know if there's some issue that they need to deal with, and that's the capability you can only get with a body area network. There's really no other way to do that.
We came out of COVID first. I described that in my book, my conversations with Albert Bourla of Pfizer, and I persuaded him to give tiny Israel the necessary vaccines to get us out first from the COVID. And the reason I could do that is because we have a database, 98%, a medical database. 98% of our population has digitized medical records and little card. And anywhere you go in any hospital in Israel, north, south, doesn't make any difference. Boom, you punch it in and you know everything about this patient for the last 20 years. I said, we'll use that to tell you whether these vaccines, what do they do to people, not individual people, not with their individual identities, but statistically, what does it do to people with, meningitis? What does it do to people with high blood pressure? What is it? You want to know that. So Israel became, if you will, the lab for Pfizer. And that's how we did it. We got it out and we gave the information to the world. Not only, it's been published in medical magazines and so on. That's a database we have. I intend to bring on that database of personal medical records for entire population, a genetic database, genomes, okay? Give me a saliva sample, volunteer. But I'm sure most people would do it. Maybe we'll pay them. Now we have a genetic record on a medical record of a robust population. You have to have diversified populations. We have people from 100 lands. This is a very powerful engine. Now let pharma companies, let medical companies, let them run algorithms on this database, okay? I'm telling you right away that I'll give preference for a few years to Israeli firms, but you can create, and then to the world, but you can create, a biotechnological industry that is unheard of right now, unimagined even. And these are just the examples. So we can become stave off Iran, become a light unto the nations in groundbreaking technologies.
What you're seeing here, this revolution that you're seeing from 2007 to 2017 is a revolution that is changing our world both economically and in terms of security. I think it'll also change our politics. And what it is basically the meeting ground between big data, IT, and connectivity. Everything is being driven from this nexus. Everything. For example, new industries are being formed. What's the first new industry that's being formed? It's right here in this room. It's the cybersecurity industry. Big data, AI, connectivity. Okay? There are many other industries that are being formed. Big data, connectivity, artificial intelligence. Let's go back to cyber. That's the first industry because everybody else needs it. And here's what's happening to the Israeli cyber industry. It's growing, obviously, in sales. It's growing in terms of market share. In 2014, we were 10% of the market share of the global private investment in cybersecurity. By 2017, it's doubled. That's a very quick doubling. And it is now second to the United States. That tall tower there is the United States. The United States is bigger than Israel. But it ain't that much bigger than Israel. And Israel is number 2. Israel is 0.1% of the world's population, and we are receiving 20% of the global share in private cybersecurity investments. That's 200 times our weight in the world. What this revolution is doing, big data, AI, and connectivity, is allowing small countries to be big countries.
But we have to fight with the weapons that apply to the battlefields in which we're engaged. And the most important ones are the social media. And the most important purchase that is going on right now is class TikTok. TikTok, number one. And I hope it goes through because it can be consequential. And the other one, what's the other one that's most important? X. Exactly. Very good. And, so we have to talk to Elon. He's not an enemy. He's a friend. We should talk to him. Now, if we can get those two things, we get a lot. And I could go on other things, but that's not the point right now.
Technology is changing the art of war. Predictably, AI will alter war more profoundly than any technology since nuclear weapons. The most significant change will be speed. Speed in weaponry, decision-making, detection, attack, and defense. Artificial intelligence will take center stage in the theater of war. It already plays a meaningful role on the battlefield.